All right, guys. Hope you all had a good weekend. Welcome back. Hope you guys are staying safe, finding things to do besides all the schoolwork. But all right, today we're going to be solving log equations. So this is a continuation from, I guess, from Friday's lesson, where we learned those 3 log rules. We're going to be using those log rules today to solve logarithmic equations. So for this warm-up, we've done a lot of going from log form to exponential form. So I thought we just practice going from exponential form to log form. All right, so take a minute, pause the video, and try the 3 problems for the warm-up. All right, so converting between the 2 forms, we know if we have log base b of a is equal to something, let's call that y. Well, we know in exponential form, right, that becomes, well, the base is b, right? This is the what power function, so what power, the power is y. What power of b equals a. So now we're just going in reverse, right? The way I like to think about this is this 3, right? That is the base, so log base 3 of, well, of 81 is equal to 4, right? Because in exponential form, it's 3 to the 4th power equals 81. So the part people mess up is where does the 81 and where does the 4 go? So once I get to this step, this is what I like to do. I think log base 3 is equal to what power? So I see the power. The power is 4, so I know it's equal to 4, which means the 81 has to go there. Right, for this one, our base is x, so this is log base x of, well, what power of x is equal to 25? I know the power is 3, right? So 3 goes there, x to the 3rd is 25, log base x of 25 is equal to 3. Right, and this in log form, this I guess we can make our general case, right? Log base b of k is equal to our exponent or power r. All right, so how are we going to solve some equations now? So here's some practice. Find the exact value of t here. So we're solving for something in our exponent. So here's what we do. We isolate the base with the exponent first. So I'm going to divide both sides by 5. And I get e to the 2t is equal to 3. So to get this out of the exponent, we're going to be using our log rules. So what I could do at this point is take the log of both sides. So I can take the log of e to the 2t, and I can also take the log of 3. And if you want, well, now we can use our log rules. Don't we know that we can bring this to the front of our log? So I can say 2t times the log of e is equal to the log of 3. All right, and remember, log of 3 and log of e, these are just quantities. You can type this into your calculator, it's just equal to a number. All right, so solving for t, we're going to get 2t equals, I'm going to divide both sides by log e is equal to log of 3 divided by log of e. And then I'll divide both sides by 2. And there we go. That is an acceptable final answer for exact value. I'm going to write this a much better way in a second, right? But yeah, we can write it like this. And just be careful. There is no log rule that lets us simplify this, right? So if you want, you can copy and paste the rules from last time, and you won't see anything that lets us simplify that. All right, so that is the exact value. What is this approximately equal? Well, let's find out real quick. Log base, well, log of 3 divided by 2 log of right? And these are just the common log. So this is around 0.54, 9, 3, etc. Right, and all right, so that's that. But like I said, this was not the best way to do this problem, because instead of taking the log of both sides, what might have been smarter to do instead of taking the log of both sides? Well, if our base here is e, wouldn't it make much more sense to take log base e, or in other words, take the natural log of both sides? So let's see what happens if we take the natural log of both sides. We're going to get the natural log of e to the 2t is equal to the natural log of 3. And then when I move the 2t to the front, I get 2t natural log of e is equal to the natural log of 3. Well, what is ln of e equal to? If you're not sure, type into your calculator, but we should know this is saying, remember the base here is really e, it's log base e, so it's saying e to the what power is equal to e. And we know e to the first power is equal to e. So this simply becomes 2t times 1. The natural log of e is 1. Right? So it becomes 2t equals the natural log of 3. So t equals the natural log of 3 divided by 2. And if you want to confirm, you can type that into your calculator too, and you will see it's the same thing as what we found before. Natural log of 3 divided by 2. Yes, also 0.54930, etc. Right? So both were acceptable, but this is a lot cleaner and a lot nicer looking, this version. I like this one. This is an interesting problem. We got nested logs. I'm taking log base 4 of log base 2 of x, and that's equal to a half. Right? So I'm going to change this to exponential form, because let's ignore this. Let's just pretend that this is, I don't know, x in there. Well, if I change this to exponential form, wouldn't this be 4 to the half power is equal to x, right? Well, what is x? X is just log base 2 of x. Well, can't I just change this also to exponential form? So it's with nested logs, I'm just doing from log to exponential form conversions. Right? And of course, 4 to the half power is 2. So 2 log base 2 of x. And from here, it's very simple. Right? Log base 2 of x is what power of 2 is x? Well, the power you're telling me is 2, so 2 squared is equal to x, and x is equal to 4. Cool. All right. Next one, what is the natural log of e to the 3rd power times natural log of e to the 5th power? All right. So what I'm going to focus in on first here is the natural log of e to the 5th power. What is the natural log of e to the 5th power? Well, again, that means e to the what power is e to the 5th. So e to the 5th power is e to the 5th. That's just equal to 5. So this is equal to natural log of e to the 3 times 5, or 15. And now it's asking, e to the what power is e to the 15th? E to the 15th power is e to the 15. This is just equal to 15. Cool. All right. And here, changing this to exponential form, we get 3 cubed is equal to x squared plus x minus 3. And we got this nice quadratic to solve. So I'm not going to talk through this. I'm just going to do it. What is that? Minus 30. And then plus 6 minus 5. And we get 2 solutions, x equals -6 and x equals 5. And let's box both answers in. All right, and yeah, I'm just going to box both answers in box both answers in, but there's really something else I should be doing, which I'll talk about in a second. But that's that. So let's practice solving some log equations. And whenever we solve log equations, we're going to have to remember to do something that we didn't do over here yet, all right, which I want to talk about. So let's solve this log equation. This time we got to use our log rules to simplify, right? Because I can use a log rule to make this into one logarithm. So step one is to combine everything to one logarithm if you can. So we have the addition of two logs, which means I can multiply the arguments because they have the same base. So this log base 2 of x times x minus 3, and that's equal to 2. All right, changing this now to exponential form, I have 2 squared equals x times x minus 3, which is x squared minus 3x. So quadratic again, I get x squared minus 3x minus 4 equals 0. Factor this, what is this? X minus 4, x plus 1 equals 0. And I get solutions of 4 and negative 1. Right? And I'm just going to box my answers in. So what do we need to remember to do? Well, anytime we're dealing with a function that has a restricted domain, where it's undefined for some x values, well, we need to check our answers. You guys remember when we solved square root equations? You always have to check your answers in a square root equation because some of them might be extraneous solutions. So that is the same case here. And if we plug in a negative 1, right, we can see that it's going to be undefined because, again, this x value has to be greater than 0. The domain of a log function is x greater than 0. So we're going to have to reject this answer. We're going to have to reject this answer. And the only answer that's actually going to work is 4. So let's plug in a 4 and also check if that works. You plug in a 4, right? All our log expressions are defined, and it should work out. So remember to check. And sometimes checking with logs, it's a pain. So the way I'm going to check is by graphing them. So I'm going to switch my screen that I'm sharing now to Desmos, so we can see how to check on the calculator. All right. I think I'm screen sharing this now, hopefully. I don't know, am I sharing anything with you guys now? Resume share. Oh, I'm sharing the wrong thing. Let me close this. All right, share screen. I want to share this. All right, there we go. So I just typed those logs in before. All right, so what we're checking is log base 2. All right, if you want log with a different base, you have to go all the way over here in miscellaneous and get into functions on your calculator. It's quite simple. So you got log base 2 of x plus, let me copy this, log base 2 of x minus 3. And we want to see when that is equal to 2. So I'm going to graph both sides of my equation. And you can see there's only one point of intersection at 4. When x is equal to 4, they both equal 2. So remember to check. There is no solution of negative 1. They do not intersect at negative 1. All right? So if we go back to the previous question, the log base 3 of x squared plus x minus 3, let's take a look at that one. That was log base 3 of x squared plus x minus 3 and y equals 3. So in this one, we got x equals negative 6 and x equals 5. Both solutions here are actually valid. So we didn't have to reject anything. And hold on, I think. All right. I don't know how long I wasn't sharing for, but here's the graph of log base 3 of x squared plus x minus 3. I set that equal to 3. And you can see both solutions are points of intersections at x equals 5 and x equals -6. Right? So for all these log functions, we really need to be checking every single time if our solutions make the function undefined or not to see if it's valid. So just like you do with square root equations. All right? So resume. You must check your answers. All right, you must check answers. And you can check your answers either graphically or algebraically. So again, when we graph this guy, we got that was what the log function looked like. And there was y equals 3, and then yes, we did get two solutions at 5 and -6. Right, when we graph this one, there's only one point of intersection, so make sure you are checking. Right, number 2, log base 2 of that equals 2 plus log base 2 of that. Again, when you have multiple logs, let's combine them using our log rule. So I'm going to get those two logs on the same side. Log base 2 of 5x minus 1 minus log base 2 of x minus 2 equals 2. So using our log rule, when we're subtracting logs with the same base, we can make that a quotient. We can make that division. So log base 2 of 5x minus 1 over x minus 2 equals 2. And then we're going to go from log to exponential form, which means 2 squared equals 5x minus 1 over x minus 2. And I'm pretty sure you can solve this simple rational equation here. All right, we're going to get 4 times x minus 2, or 4x minus 8 equals 5x minus 1 after cross multiplying. And we get x is equal to -7. All right, so let's solve for this. Not solve, let's check. All right, so plugging in a -7, I notice I'm going to get negative arguments. You cannot take the log of a negative number, right? Because again, let's just plug in negative, what was the answer again? -7. Let's just plug in -7, we're going to get log base 2 of -9. Again, this is saying 2 to the what power equals -9. You can't raise a positive number to any power to get any negative number. So this means there is no solution. We have to reject this answer. And our solution is that there are no solutions. Right? Easiest way to check this is to, again, graph the left side of the equation, the right side of the equation, and look for points of intersection. So in this case, these two graphs are never going to intersect. All right, I would show you on Desmos, but I don't want to keep switching back and forth. It gets kind of finicky when I do, I think, for recording. But all right, so next one. We got the natural log of x equals all of this. Interesting. So what should we do here? Well, I see it's a half power, so I can raise that to the half power. So using one of our rules, we know anything we're multiplying a log by, that's the same thing as raising the argument to that power. So this is natural log of 2x plus 5 over 2 to the 1/2 power plus the natural log of 2 to the 1/2 power. All right, so now we got the natural log of x equals, well, I'm adding these two logs so I can multiply the arguments together. That's going to be the natural log of 2x plus 5 over 2 to the 1/2 power times 2 to the 1/2 power. And I could go ahead and multiply the bases together, right? Because if we have the same base, sorry, not the same base, but if we have the same powers, right, we're allowed to multiply the bases. For example, if you have, I don't know, a to the x power times b to the x power, isn't that just ab to the x power, right? So I could change this to the natural log of 4x plus 5 to the 1/2 power. Maybe it might help if you're confused about that to think of it in terms of square roots, right? If you have the square root of 2x plus 5 over 2 times the square root of 2, right? We know we're allowed to multiply the radicands together. So that might be easier to think of. Right, and that's equal to the natural log of x. All right, so this one is an interesting example because, well, I'm not going to change this to exponential form. What I'm going to do instead is look at the two arguments because I am taking the natural log of both sides, right? So if I'm taking the natural log of x and the natural log of 4x plus 5 to the 1/2 power, well, in order for the left side to equal the right side, well, those arguments must be equivalent, right? Just like you can take the natural log of both sides, we can take the inverse natural log of both sides and just get rid of the natural logs. And so x equals 4x plus 5 to the 1/2 power. And now we're solving a square root equation. So change it to that, square root both sides. Not square both sides, square both sides. We get x squared equals 4x plus 5. And again, those are quadratic now. And let's factor x minus 5, x plus 1, solutions of x equals 5, and x equals -1. So when I check, I can see that the -1, again, that's going to make it undefined. You can't take the natural log of a negative number. So we're going to have to reject this -1. And we should also really check the 5 also, because there's a lot of stuff we did. First of all, the 5 is going to keep the square root okay. And plug in the 5 here or there. I don't see any problems. So 5 could be a valid answer. If you want to check algebraically, plug in a 5 and then have to do all this kind of weird, messy work. So for log equations, that's why I recommend doing it graphically. So I would graph the left side and the right side. I guess I should show you this one. Let me change my mirroring to Desmos again. All right, so this one, again, let's graph natural log of x and 1/2 times the natural log of 2x plus 5/2 or 2.5 and plus 1/2 natural log of 2. Right, and by the way, all of this is just equal to a number. And look at that, they intersect at 5, which is the solution we got. And we can see there's no intersection at -1. All right, very cool. Let's go back to my iPad now. All right, and I'm only going to be doing one more problem with you guys, and then the rest is on your own. I'll give you the answers though. All right, so number 4 here. Again, let's use our log rules. You can combine those two. That becomes log base 3 of, I'm just going to multiply out now, x squared minus 2x, distribute out to x, equals log base 3 of x plus 10. So this is the same scenario as above, right? I'm taking log base 3 of this and log base 3 of that. So this must equal that if they are to be equivalent. So x squared minus 2x equals x plus 10. And I keep giving you quadratic equations, but you can really end up with all sorts of different kinds of equations. You can get up with square root equations or complex fractions even when you do these log equations. So make sure you're still capable of solving other kinds of equations. But we get solutions of 5 and -2. Right, you can check your answers graphically, but again, we just got log base 3 of x here. If we plug in the -2, we're going to have to reject that answer. And just 5, again, as a solution. So when you're solving log equations, in general, you just want to condense the logs as much as possible, right? If you have multiple logs on both sides, try to get them on the same side and then change it to exponential form, right? In a scenario where you end up with logs on both sides and you can't really go any further, you can just set the arguments equal to each other. And yeah, you can actually also, now that I think about it, actually, let me see if this works. You can also subtract log base 3 of x plus 10 on both sides, right? And I think this should work also. I don't see why it wouldn't. Not the way I would do it though, but I just want to test this out and make this equal 0, right? You can simplify the left side using the quotient rule, where subtraction is the division. So that's log base 3 of x squared minus 2x over x plus 10 is equal to 0. And then we get 3 to the 0th power, or 1, is equal to x squared minus 2x over x plus 10. And cross multiplying, aha, we're going to get to that step. And that also works. So you really got a lot of options to solve these log equations. Yeah, but if you got this scenario, much easier to just set the bases, not the bases, sorry, the arguments equal to each other, right? But yeah, that's pretty cool. That also worked. So I imagine it also worked for this one if you just got all the natural logs on one side, right, and combine it using your log rules, made it equal 0, and then did e to the 0 power. Ah, pretty cool. All right, so anyway, here are some more problems to try on your own. If you don't want spoilers, I'm sorry. Go ahead, try those on your own. You can pause the video now. All right, so assuming you've done them here, you go, you can check your answers. All right, pause the video. Here's 1 and 2. Pause the video. There is number 3. And there's number 4. All right, if I made a mistake on one of these, let me know. Or if you have any questions, let me know. All right, but make sure, again, with logs, just like with square roots, you are checking your answers, right, algebraically or graphically, and making sure your answers do not make a logarithm undefined, right, and make sure you're rejecting extraneous solutions. So that's going to be it for today. I think I posted on Google Classroom already. Test next week on Monday. All right, so try to keep up to date with stuff and stay safe, guys. I hope you and your families are doing good. Yeah, looks like I'll be seeing you guys most likely in September. So happy you guys are still sophomores and juniors. So good to see you guys around. See you guys later. Bye-bye.